Alright, let's graph some linear inequalities. Alright, so let's put this in slope-intercept form. That means we're going to solve for y. Okay, so I need to isolate this negative 3y. Let's subtract 2x on both sides. We get negative 3y is greater than negative 2x plus 6. We're putting it in slope-intercept form, so I need y equals mx plus b. Okay, I know the equals 2 sign's not really an equals 2 because it's an inequality, but you get my drift. Alright, so now I need to solve for y. I've got negative 3 times y, so we're going to divide by a negative 3 and get the y by itself. Now, we were dividing by a negative, so when I divide by a negative, I must flip my inequality symbol. So it's y is greater than, it's going to flip to become y is less than. Negative divided by negative is a positive, so positive 2/3 x, and then we would have minus 2. Now, to graph this, we're going to start at our b, our begin, so negative 2, go down 2, bam, there it is. We're going to go up 2 over 3, up 2 over 3, and now we're going to connect these points with a dashed line. It is a less than symbol. We connect them with a dashed line. If you don't see a line, you don't draw a line. What that means is that all my points on that line are not solutions to my inequality. Alright, y is less than, so we're going to go right here, less than, we're going to go underneath the graph, and we're shading down here. So I'm shading because all of those points that I'm coloring in right now are solutions to the inequality. They all make that inequality true. Number 40, same thing. I want to solve for x. I want to get it in slope-intercept form. Solve for y and get it in slope-intercept form. So let's subtract 4x on both sides. And we get y is greater than or equal to negative 4x plus 1. Now, I don't have to flip the inequality symbol because all I did was subtract 4x. I didn't multiply or divide by a negative. So y is greater than or equal to negative 4x plus 1. Here's my begin. Here's my b. So we're going to start at positive 1. From there, we're going to go down 4 over 1, right? So down 1, 2, 3, 4 over 1. We have a negative slope. Down 1, 2, 3, 4 over 1. Now, this inequality symbol is equal to. So if it is an equals to symbol, we connect those with a solid line. If you see a line underneath, you draw a line. And now it's greater than, so I'm going to shade above the graph. So we're going to go to our y-intercept. Above the graph would be up here. And again, all of those are solutions to my inequality. All right, let's look at some properties of exponents. So looking at 41, if I have a negative exponent, the way to make it a positive exponent is we change what level it's on. So right now it's in my numerator. I'm going to move that to the denominator. So it's going to become 1 over x to the 5th. When you move it to the denominator, it becomes a positive exponent. We have 1 over x to the 5th. 42, same thing. I have a negative exponent here. So it's going to become y to the 7th. Now, z to the 0, anything to the 0 is equal to 1. So I don't really need to write that. This x to the negative 5 is in the numerator right now. It's going to go to the denominator. So x to the positive 5, just like we did over here. So I've got y to the 7th, x to the 5th. Now, those are not like terms, so you cannot simplify any further. 43, I've got 6m into the negative 4, so we know that n to the negative 4 is going to need to go to the bottom. This q to the negative 2 is going to need to go to the top. And then we know this p to the 0 is going to be equal to 1. So in my numerator stays 6m. I'm bringing this q to the negative 2 to the top, and it's going to become q to the positive 2. And my denominator is going to go into the negative 4. It's going to become into the positive 4. And then this p to the 0 is going to be 1, so you don't need to do anything there. Number 44. Everything inside this parentheses is raised to the 3rd power. So that would become 2 to the 3rd, x to the 5 to the 3rd, y to the negative 2 to the 3rd, and z to the 1 to the 3rd. Okay? Now, we have powers raised to powers. When you have powers raised to powers, you're going to multiply the exponent. So we have 2 to the 3rd power. So that's going to be 2 times 2 times 2, which is equal to 8. We have x to the 5th 3 times. So we have x to the 5th, x to the 5th, x to the 5th. So 5, 10, 15, we have x to the 15th power. Not x to the 8th. We're going to multiply 5 times 3 and get x to the 15th. Same thing, I have y to the negative 2 3 times. So I'm going to take this negative 2 and multiply it by 3, and I get y to the negative 6th. And then I've got 1 times 3 here, so I've got z to the positive 3. Now, we're not quite done because I see a negative exponent here, so I need to change what level it's on. So my numerator, I've got 8, x to the 15, z to the 3rd. Those don't need to move because those are positive. This y to the negative 6 needs to go to the bottom, and it's going to become a y to the positive 6 when I move it to the denominator. 45, same thing. I've got 2 raised to the 4th. I've got c raised to the 3rd raised to the 4th. So 3 times 4 is c to the 12th. d raised to the 8th, because 2 times 4 is 8. Now I've got this one, 2 raised to the 2nd power. 2 raised to the 2nd power is 4. a squared raised to the 2nd power would be a to the 4th. And then c to the 1st to the 2nd would be c squared. Alright, 2 to the 4th is 16. So we have 16. c to the 12th, d to the 8th, times 4, a to the 4th, c to the 2nd. Alright, now 16 times 4, right? I can multiply coefficients. Okay, 16 times 4 is 64. I've got c to the 12th, and I have another c to the 2nd, right? So c times itself 12 times, and then another 2, that's going to be c to the 14th. That's not a power raised to a power. All we're doing is multiplying, so I add my exponents here. That's totally different than I have a power raised to a power. If you have a power raised to a power, you multiply. So I've got d to the 8th, no more d's, so leave it d to the 8th. I've got a to the 4th, no more a's, so a to the 4th. Alright, looking at number 46, okay, I have the same thing in the numerator and the denominator. Okay, so I can cancel those out. Alright, so if I'm looking, I've got 16 and 96. So I can simplify there. They're both divisible by 4. Alright, so this 16 divided by 4 is going to give me 4. Oops. I've got 96 divided by 4. That's going to give me 24. So I can simplify even further. Okay, I've got x to the 5th over x to the 2nd power. So if I have a same exponent in the numerator and the denominator, same variable, I can subtract exponents. So 5 minus 2 is going to give me x to the 3rd. We know that x to the 5th is greater, so the x to the 3rd is going to stay in the numerator. Alright, so what I'm doing right now is I've got x to the 5th, so x times itself 5 times, over x to the 2nd. Well, if you have the same thing in the numerator and the denominator, you can cancel them out. So you can see that we have x to the 3rd left in the numerator. Same thing with my y's. I've got y to the 3rd, I've got y to the 9th. So 9 minus 3 is 6. But now the biggest exponent is going to be in the denominator, so the y to the 6th is going to stay in the denominator. Now we're not quite done because this is able to reduce also. So 4 and 24, we can divide that by 4. It's going to be 1 in the numerator, x to the 3rd, and the denominator is going to be 6y to the 6th. So do I really need to write the 1? No. It's going to be x to the 3rd over 6y to the 6th. Alright, so number 47, I've got 5xy to the 3rd raised to the 0. So this would be 5 to the 0, x to the 0, y to the 0, over 7 raised to the 0, x squared raised to the 0, and y raised to the 0. 5 to the 0 is 1. X to the 0 is 1. Y to the 0 is 1. So in the numerator, we've got 1 times 1 times 1, which is 1. In the denominator, I've got 7 to the 0, which is 1. X squared to the 0 is 1. Y to the 0 is 1. So it's equal to 1. Number 48 says, which expression is equivalent to negative 2x squared, y squared? Alright, so let's look. I need a negative 2. So if I take this and distribute it here, I've got 2 raised to the negative 1. Now to make that a positive, that needs to go to the denominator, right? So this would become 1 over 2. That's not what I want. I need a negative 2. So A is wrong. B, I've got negative 2. Good. I've got x to the 3rd. I've got x to the 1st power here. So if I have a power, same exponent, the same variable on the top and on the bottom, I can subtract exponents. So 3 minus 1 is 2, x squared. I've got the same variable here, so 4 minus 2 is 2, and it needs to stay in the denominator because that's the biggest exponent. So B is the correct answer. I've got negative 2. My x's are going to subtract. 3 minus 1 is x to the 2nd power in the numerator. 4 minus 2 is x to the y to the 2nd power in the denominator, which is B right there.